in the area of science and huge mysteries the subject of what existed before the colossal explosion has blended conversations and intrigued thinkers for quite a while. This critical question doesn't just test our understanding of the universe, it challenges the genuine limits of human knowledge. Imagine standing at the edge of existence, looking into the immense darkness and wondering what lay there. Before our universe was conceived, the event of the Big Bang marked the beginning of time, space, and all that we know. But was there a moment before this? Could there have been a state of nothingness, a calm before the spectacular gathering began? If this is true, was it truly empty, or perhaps something even more profound existed before time itself? As we delve further into this question, science takes us on a journey beyond the universe's starting point into ideas that defy our understanding. Physicist Brian Cox, known for his investigations into the wonders of the universe, suggests that something unexpected might have existed before the Big Bang. He challenges us to rethink our concept of reality and existence. In this examination, we'll explore the science, the theories, and the staggering mysteries that might explain what existed before everything. We'll investigate ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may surprise you, but they could also open new understandings of our place in the cosmos. Prepare to dive deep into a realm beyond imagination, a scientific domain where the unknown still casts shadows, leaving experts astonished and at times unsettled. Let us explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To grasp what might have existed before the Big Bang, we first need to carefully examine what the Big Bang truly was. The Big Bang, as researchers define it, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to trigger the creation of all matter, energy, and fundamental forces. When we look into the night sky, we see evidence of this fiery beginning, with galaxies spreading out in all directions from a primordial point. But why did this happen, and was there a time before this dense hot start? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or quiet. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched out, essentially like a vast vacuum. However, this vacuum wasn't entirely empty. It contained an enormous amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it effectively laid the groundwork for everything that followed. In a fraction of a second, space expanded at incredible speeds until the expansion slowed and the energy transformed into matter, particles, and the forces we observe as the Big Bang. But what was the nature of this energy? Why did it suddenly expand the universe, and why did it stop? Researchers believe that this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching infinitely with tiny bubbles forming here and there, each bubble representing a universe including our own. This idea, called the inflationary multiverse, suggests that there are potentially infinite Big Bangs and an endless number of universes. Our own is just one among many. This vast, mind-bending reality challenges our perception of the very universe itself and leaves us with a question: what else is out there? The concept of nothingness before the Big Bang is speculative, not definitive, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that we an inescapable tapestry of something, even in its most vacant form. Even if we imagined stripping away these forces, leaving a dead emptiness, the universe would still generate new forms of energy. This fact alone puzzles researchers, as it suggests that true nothingness may be impossible within our cosmic understanding. As we probe further, we discover that space itself has properties, rules, and constants that prevent it from being entirely empty. Imagine creating a region with absolutely nothing in it, no particles, no radiation, and no energy, except quantum fields and fundamental constants. These would still exist, implying that even this nothingness has properties. For instance, there is a phenomenon called Z-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still briefly appear and vanish, creating a ghostly echo of activity even in what should be empty space. This challenges our concept of a true void and suggests that yes, even before the Big Bang there was something that scientists are only beginning to understand. One of the most astonishing hypotheses in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's possible it could continue endlessly. Brian Cox describes an alarmingly vast inflationary multiverse where universes are perpetually created and continue expanding. Imagine each Big Bang as a spark igniting another universe, while inflation continues in other regions, creating countless other universes. This process could in theory continue forever. This idea of infinite universes gives rise to a captivating concept of a fractal universe where each new universe could potentially create its own Big Bang. Each universe exists as a separate, independent domain unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling, as it suggests an eternal multiverse with no definitive beginning or end. What if our universe is just one spot in a giant cosmic structure, endlessly expanding and creating more and more? And what if the unsettling truth is that there is no before or after, but only an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not merely a collection of matter floating in space, rather it is an intricate network of energy fields that fill the cosmos, interacting to create everything we observe. These fields are like invisible oceans with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields momentarily, borrowing energy before returning it. This phenomenon gives rise to virtual particles, entities that briefly exist and then vanish, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have absolute nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields remain active, sometimes producing transient particles. Steady development in the field ought not to suggest that the universe recognizes our concept of emptiness. The fields and forces persist, filling the universe with a mysterious energy that prevents absolute nothingness. This understanding raises a fascinating question. If fields create particles and particles create matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is a mysterious force currently driving the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to some scientists, it's possible that dark energy is a remnant of an energy field from before our universe's formation. The properties of dark energy suggest a vast enigmatic force that may have existed in some form before the Big Bang. Some theories propose that dark energy in a much stronger state could have powered the inflationary phase, causing rapid expansion. The presence of dark energy implies that even if our universe were emptied of all matter and radiation, this force would continue to stretch the fabric of spacetime. This idea leads to an intriguing question. If dark energy was present before the Big Bang, could it have shaped the conditions that led to the birth of our universe? Could dark energy be the silent architect of cosmic expansion, or even the true origin of our universe. As we explore this possibility, we face the potential of dark energy not only as a force shaping our universe but also as a key to unlocking the secrets of the multiverse itself. Another theory, offering an alternative to the Big Bang as the ultimate beginning, is cyclic cosmology. This model suggests that the universe undergo endless cycles of birth, death and rebirth. In this view, the Big Bang is not a one-time event but part of an eternal rhythm where universes expand, collapse and then renew themselves in another cycle. This hypothesis implies that our universe may have been renewed from the remnants of a previous one. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, only an infinite series of universes emerging, evolving and reviving themselves endlessly. Cyclic cosmology raises profound questions about time, as it suggests time itself may be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give rise to our current cosmos. For scientists, this hypothesis offers a compelling answer to the question of ultimate origins, suggesting that there is no true beginning. The universe has always existed in some form, transcending our notions of time and existence. Primordial gravitational waves are another fascinating concept that could hold clues to what existed before the Big Bang. Gravitational waves, ripples in spacetime caused by massive cosmic events, might carry information about the universe's earliest moments. Some theories suggest that gravitational waves could originate from a pre-Big Bang era if such a period existed. Detecting these waves could provide direct evidence of events or conditions before inflation and the hot Big Bang. However, identifying primordial waves from before the Big Bang poses a significant challenge. Scientists are developing highly sensitive instruments to detect these subtle signals, hoping one day to uncover a hidden layer of cosmic history. Such a discovery would not only answer questions about the universe's earliest stages but also reveal deeper cosmic forces that may have ignited its existence. Quantum foam, a concept proposed by physicist John Wheeler, offers another hypothesis, hinting at pre-Big Bang existence. According to quantum mechanics, space is never truly empty but is filled with constant fluctuations of energy at the smallest scales. This quantum foam suggests that at the tiniest scales of reality, particles can appear and disappear in fleeting moments, creating brief pockets of energy. This idea supports the vacuum genesis theory, which posits that the universe could have emerged from a massive quantum fluctuation in the sea of quantum foam. The vacuum genesis theory redefines the concept of nothingness, suggesting that even in the absence of matter, energy and conventional spacetime, a dynamic reality exists. If our universe is indeed the result of a fluctuation in quantum foam, there could be other universes arising and vanishing within this quantum sea. This notion expands the multiverse hypothesis, implying that our universe's existence may be far more ordinary in the grand scheme of cosmic phenomena. Quantum tunneling, a phenomenon in quantum mechanics where particles pass through energy barriers despite lacking the required energy, is another concept with implications for the universe's origin. Some cosmologists propose that our universe could have tunneled into existence from another domain or plane of reality. This theory adds a mysterious layer to what existed before the Big Bang, suggesting that our universe may have spilled or tunneled into being from a different realm. If true, our universe could be one of many, forming, evolving, and vanishing within a much larger cosmic structure. Quantum tunneling implies that the Big Bang might not have been the beginning but rather the result of a boundary being crossed, a moment when our universe emerged into the vast unknown. As we explore these theories, it becomes clear that our understanding of the universe's origins is limited, but evolving. The Big Bang was once thought to be the definitive starting point from which all existence sprang, but now with ideas like inflation, the multiverse, and Quantum fields we see are far more complex. Tapestry scientists like Brian Cox encourage us to imagine that something existed before our universe, something powerful enough to ignite the Big Bang and set the chain of events leading to our cosmos in motion. The implications of these theories are both exciting and humbling, reminding us that the universe is full of mysteries yet to be solved. So, what existed before the Big Bang? While science may one day reveal more answers, for now we stand at the edge of the known, gazing into the unknown with curiosity, wonder, and a hint of fear. The vastness of the universe, its intricate designs, and the secrets it holds remind us that our place in the cosmos is both extraordinary and fleeting. Embracing this mystery is part of what makes us human, driving us to continue exploring as we delve deeper into the mysteries of what may have existed before the Big Bang. It's crucial to consider the role of theoretical physics in shaping our understanding. Ideas from quantum mechanics, inflation, and the multiverse highlight one fundamental concept: the universe is far more complex than we initially imagined. Even the concept of time as we understand it might not have existed before the Big Bang. In some interpretations of physics, particularly quantum gravity and string theory, time is seen as an emergent property of the universe rather than an intrinsic feature of reality. If this is true, time itself may have come into existence only when the conditions for space and matter were set into motion during the Big Bang. Before this moment, there may not have been a before in any conventional sense, just a timeless state that defies human perception. Some cosmologists speculate that the laws of physics as we understand them might not have applied before the Big Bang. In this pre-universe state, the principles of causality which govern how events unfold might not have been active. This suggests the possibility that the usual rules of cause and effect could be entirely different or irrelevant. In this early state, the Big Bang might not have been a singular defining event, but rather part of an ongoing cyclic process of cosmic evolution. Such a theory aligns with the idea of a big bounce where the universe contracts to a singularity before expanding again. This hypothesis offers a potential solution to the question of ultimate origin, suggesting that our universe's birth may have been preceded by a previous cosmic collapse, leading to an eternal cycle of birth, death, and rebirth. These ideas underscore the limits of human knowledge while highlighting how close we may be to uncovering a new chapter in our understanding of the universe. Each new discovery, whether through the detection of primordial gravitational waves, further exploration of quantum fields, or theoretical advances in string theory, may one day provide insights into the very nature of existence itself. The journey toward these answers may not be swift, but the quest remains one of the most exciting endeavors in science today.